Hi folks, we're going to take a look at number 23 on page 420. So they give us this information about two vectors x and y. So they give us the magnitudes and they tell us that the angle between them is 60 degrees, and they want us to determine the value of this expression. All right. So here, instead of trying to determine this vector x minus 2y, which we actually could do since we have the magnitudes of x and y and the angle between them, we can set up a diagram and determine this vector and do the same thing for this one here, and then take the dot product. It makes a lot more sense to make use of the distributive property of the dot product to write this expression in terms of a bunch of simpler ones. All right, so first thing I'm going to do is I'm going to distribute this using the distributive property. So here I have x dot x. All right, so then here I've got 3 times x dot y, so plus 3x dot y. Here we have negative 2y dot x, so minus 2y dot x, and then finally we have negative 6y dot y, so minus 6y dot y. All right, so that's what this expression is written as. So what I have is, while I now have 4 expressions, they're much easier to work with. So one of the things we definitely need to know is that a vector dotted with itself is equal to the magnitude of that vector squared. So this is equal to magnitude of x squared. We also know that dot product is commutative, so these are like terms. So it's going to be 3 minus 2, so plus 1 x dot y, or y dot x, doesn't matter which way we put it. And then here we have, again, that a vector dotted with itself is just the magnitude squared. So this is negative 6 times the magnitude of y squared. All right, so they gave us the magnitude of x, it's just 2, so 2 squared. Okay, now here we have the magnitudes of x and y, and we know the angle between them. So we can apply the geometric definition of dot product, okay, which is the magnitude of x, so that's 2, times the magnitude of y, which is 5, times the cosine of the angle between them, cos 60. Okay, and then here again, 6 times magnitude of y squared, so times 5 squared. All right, and so now we realize that we've got all the information necessary to calculate this here. So we have 4 plus, so this is, again, cos 60 is 1 over 2, adjacent over hypotenuse. So this is just going to be 2 times a half is 1. So here 4 plus 5 is 9, minus 6 times 25. So that's going to be minus 150. Okay, and so finally here we have 9 minus 150 is negative 141. All right, so just to recap here, remember that dot product is distributive. So here we can take this expression and use a distributive property to write it in terms of expressions, which are much easier to calculate than if we were actually going to determine each of these vectors independently. That would take quite a bit of time, but once we turn them into much simpler operations, we can conduct these calculations much easier. Okay, so please keep that in mind, that dot product is distributive. Something very important that we used in there is that a vector dotted with itself is equal to the magnitude squared, and we also use the fact that the dot product was commutative so that we could bring together these terms. Okay, that's it for this one.